Hello everyone, it's me Mohammad Safla Khan. Today we are going to know what is optimization. So what is basically optimization? In English, optimization means to see the brighter side. The brighter side of life, the brighter side in all the aspects of life like business, where we have to deal with we have few resources and we use it economically, cost effectively, in such a way that no one get any kind of failure in his business, or any kind of when he deal with this business, and to give customer cost effective kind of outcome, and to both the parties, customers and to the dealers. So how this, and in any case, in politics, you say, you can say, in any kind of thing, the optimization is the most important, the key role, which will change the things which are looking scarce and lower to you, can change into a form which you cannot believe. So the resources which are in limited edition, we can have hope in form of optimum approach. And this approach comes from optimization. Optimization means, you can say optimization, you can say it is utilization in a cost effective way. In a cost effective way, which I show you here, in a cost effective utilization, we use this optimization in which we have limited resources. We use the equations, we use it in such a kind of way, so any kind of business, politics, any kind of you can say the things which are looking odd, we change into an even form. So in mathematically, if we mathematically, if we want to know how it looks, it look like, you can say, we have in a business, we have z is the equation, where we have like we have a resource which is 2, it is x1, another is 3, which is x2. So you can see it is also positive, it is also positive, so it means it is in a bulk form. If here we put 5x3, it means it is in a negative form, or in low quantity. This means a profit, this means minus 5 means loss. In optimization, this is the basic form, where we see any kind of cement factory, any kind of business. This is what we have resources, this is our business name, and this is our resources, which are some positive and negative, and by this we get an optimum result, by an optimum result on base of what we can get. It is based on, for example, we have in mathematics, we have contents, which we say constraints. For example, the ST constraint, we have, for example, we can say it x1 plus we can say it 5x2 is equal to we can say we have 8 something value, and we have another value which we say x1, yeah, we can put it like this, and here we say 3x2, and we say it as 4, which we say greater and is equal to, and greater and is equal to. So basically this becomes a equation, mathematically an equation form for an optimization. And now to solve this equation, what we do, we change it into a standard form. So how can we do this? First, this is our z equation, and we change into a standard form. For standard form, we will write our equation same. Z is equal to 2x1 plus 3x2 minus 5x3. Okay, and then we convert into a z is equal to z minus 2x1 minus 3x2 and minus 5x3, like this. And then we shift it into a standard form. All the constraint we have here, this is our first constraint, and this is second constraint. As I want to tell you, we have this less than and is equal to sign here, and for this we will for its substituting, we will do slack. We will introduce slack to make it is equal to, which is our basic variable. So and these are non-basic variables, x1, x2, x3. So we can do it like this. Maybe yes. How can we do this? 2x, what we have, x1 plus 5x2 plus s1 is equal to 8. This becomes 1b. This is a slack. This is slack variable. And number 2 we have x2 1 plus 3x 2 plus s2, because s1 is used, so s2 is next, and we put and is equal to 4. So this has become our second constraint. Now what should we do? We will make a chart for to solve this equation. Let me do on the next page. For this we write basic, then we like this. We have basic z value s1 and s2 into our basic, because we take these are as a basic. And on this side, what we have x1, x2 and x3 and s1, s2 for making our chart better. After this, we will, so basically this become our table for iteration from the mathematics point of view. And this, then we use a formula by which we will choose the most negative value here we have this as our most negative value, and for this we will as we have the 0, so we not consider it. So less than it is 3, so we will choose this is our equation, pivot equation column, and after this we take a ratio. In this ratio I will tell you that we will take the most least value among it. So for this, what we do, as we know, here is we have in this column we have 5 and 3, and in solution 8 and 4. So we will take a ratio 5, 8 divided by 5, which is 1.6, and then we take 4 by 3, we have 1.33, so we write here 1.3. So basically we will choose the minimum. So this is minimum, and this is larger than this, so we choose S2 as our eliminating variable S2, and this will be eliminated on the basis of X2, like musical chairs we have. So what we gonna do, we will now make a pivot table first, where we write this as basic, like this, and here x1, x2, x3, s1, s2, and solution. With regard this z, same like here, z is here, s1, and now we replace s2 from this x2, so we replace it and we put it here x2, and what we do, we will divide this 3 with all of these values. So what we have 2 by 3 as 3 by 3 divided by is equal to 1. Here is 0, another 0, and 1 by 3, and 4 by 3. So this is become a pivot equation. And now for iteration, we will start doing iteration from this old value. This is the formula. From old value we will minus pivot equation. Let's see how it is. So we say old z equation. In this, whatever written is here, we'll put right here. -2, -3, -5, 0, 0, another 0, and here we according to formula we put minus and choose what, the column which we choose of x2 here is -3. -3 will be put it here, -3 and close, and multiply with what, our pivot equation. This is x2. All of this will be multiplied by this, and we say it is pivot. pivot equation. So what we have, this becomes 3, so we have 2 as it is plus, and 1 we have, so it is 3, and after this we have multiplied 0, then we have 0, and as 3 multiplied 3 cancels, so it becomes 1, and after this we have, as this 3 minus this, so eliminate by this, and we have 4. So our new z equation will be 0, 0, minus 5, 0, 1, and 4. This has become our new z equation. Now we have look for S1. This is our old one, so we use it again to change it. Old S1 equation. What we have? 1, 5, 0, 1, 0, 8, and like same we use equation minus according to a formula, and from here we have 5, so we write here 5 and multiply it with pivot equation, which is we have to multiply this minus 5 multiplied by this. So what we have, minus 10 divided by 3, then we have minus 5, exact 0, 0, and 5 by minus 5 by 3, and what, this minus 5 multiplied by this, so we have 20 by 3. So we have a new, so our new S1 equation will be what? So we use this calculator, we have minus 1 minus 10 by 3, we got this, minus 7 by 3, then we use 5 minus 5 becomes 5 minus 5 becomes 0, 0 is 0, 1 is 1, 0 is again come, and then we have 8 minus 5 by 3, we have 19 by 3, 20. Then we use 8 minus 20 by 3. Sorry. We have 4 by 3 here, 4 by 3. So our new, so this is our new z equation. For this we will make another table according to our past what we have done. Here we use basic, x1, x2, x3, s1 and s2. Its solution. This is our zero iteration. This will be our first iteration according to this what we have done. So z s1 and x2. So the new z equation will be what we have got here, a new. This will be put here, which is 0, 0, minus 5, 0, 1, 4. And for S1 we have this particular new equation, minus 3, 0, 0, 1, 0, 4 by 3. So, and this x2 is what we have a pivot equation which we find of very firstly. So it is 2 by 3, 1, 0, 0, 1 by 3, this is also 4 by 3. As our basic our x1 and x2 value becomes 0, so we can say according to this it will reach to an optimum solution. We got this 4 in first. When we made a basic this basic table, very first we have 0 in our solution as an outcome, and here the outcome changes into a 4 of z equation. So we can say z is equal to 0. We have reached from 1 is equal to z is equal to 4. So this is positive change. This positive change is profit, which shows that this question type is of maximization. I just want to tell you, if we have negative change, for example from, like we have here from 0 to 4, we have z is equal to 0 to z1 is equal to minus 4. If this is there is negative change, so what it means, it means it is minimization question type, and it is used for minimizing cost, where it use in form of business or anywhere, in the cement factory or any circumstances. So we can use this optimization equation to justify it. Now we will study about a new optimization type, which is MTM. technique in optimization we have a question. I just want to show you it is of minimization, which is z is equal to 4x1 plus x2 plus we have subject 2, we have 3x1 plus x2 is equal to 3, 4x1 plus 3x2 is greater than is equal to 6, x1 plus 2x2 is less than is equal to 4, x1 x2 is less than is equal to 0. So how can we solve this equation using M technique? First, we will change into a standard form. And for standard form, we will use this minimizing z like we do it minus 4x1 minus x2 is equal to 0, and we change these constraints equally, and it is how 3x1 plus x2 is equal to 3, then 4x1 plus 3x2 minus x3 is equal to 6x1 plus 2x2 plus x4 is equal to 4, with x1, x2, x3 and x4 is less than is equal to 4. Now you have a question that how this x3 and x4 comes. How this both comes? Right here we have greater than. When there is a greater than, there is a negative variable we use, and where there is greater than is equal to, like we have a slack, we use s1. So instead of this we use x3, which is positive, so that it will be look balanced. But you have to remember this: when there is a greater than, you will put negative sign. When there is less than, you will put positive sign when entering this new variables into your equations. Right here, when you finding this standard form. Okay, now we use this. Now we are going towards M technique, which is also known as method of penalty. So how can we change it? We will introduce here something M technique. For this, we will give we will introduce artificial variables, which is 3x1 x2 plus r1, because of this, is equal to 3, and then 4x1 plus 3x2 minus x3 plus r2 is equal to 6. For minimization, what we do, this set equation, we will put these new our artificial variables r1 and r2 with this, like we have z is equal to 4x1 plus x2 plus m r1 plus m r2. This m is M technique. Due to M technique, this M is very large number, large in million. For this we will introduce this M to make it equally balanced. We introduce this new model. So we have now new all variables x1, x2, x3, r1, r2 and x4 is equal to 0. This is our new equation. So what we're going to do, we will introduce here on r1 and r2 our this equation r1 as put it all over beside and r2 over here. So how can we do this? We will further do this implies that z is equal to 4x1 plus x2 here m. We will introducing this r equation at this place, which is 3 minus x1 minus x2 plus we have this r2 over here with m, and this r2, this whole equation will be come over here and we will write here as m x minus 4 x1 minus 3x2 plus x3. This is equal to z is equal to minus 4. This is all equal to, then it come like z is equal to minus 4 minus zm x1 1 minus 4 m and x2 and minus m x3 is equal to nm. This whole will be the solution. Here we have. Now what will we do? We will make a table. So how we make the table for m technique? We will write the same as lastly basic. Here is x1, x2, x3, r1, r2 and x4 with here solution. Then we have here z and here basic variable r1, r2 and x4. And lastly what we see, minus 4 plus 7m come over here, minus 1 plus 4m minus m 0 0 0 and 9m. According to our last equation, we see here 3 1 0 1 0 0 3 4 3 minus 1 0 1 0 6 1 2 0 0 0 1 4. So this basically becomes our new our first iteration table, which we say 0 0 iteration. And lastly, what I tell you how we solve this equation, I will give you directly the solution. It will reach on third iteration, which we write basic like the same x1, x2, x3, r1, r2, x4 is equal to solution, and this solution will reach to z is equal to x1, x2 and x3 0 0 0 7 by 5m minus m minus 5 by m 17 by 5. Here we reach 0 1 0 minus 1 by 5, 0 minus 1 by 5, and here is 2 by 5. Then we have x2, 0, 1, 0, minus 1 by 5, 0, 3 by 5, and 9 by 5. Then we have 0, 0, 1, 1, minus 1, 1, 1. So basically what happened, you have seen this change. R1, R2, R3, R basic becomes non-basic at this level. So this is the big change. This is like a musical chair from x1, x2, x3. Here is r1 change into x1, and then r2 change into x2, and x4 change into x3 here. This is what M technique is all about, and to know more, here is all the values on z side is 0, and here is all the values of solution is positive. So when we reach at this level, this we known as optimum solution, we find out. Now we will reach to optimization into another form, which is two phase technique method. I would say method. This technique is due to the biggest reason where we use M technique. Here we not use M technique, but we will solve in two phases. So what is our first phase? In first phase we will use another here we put minimization, not Z but R, is equal to R1 plus R2, using the same and in the past, x1 plus x2 plus x1, 3 and 4x1 plus 3x2 minus x3 plus R2 is equal to 6 plus 2x2 plus x4 is greater than or is equal to 4. So here we have R. In this we will enter R1 and R2 value into